Happy Friday. So how many people have one exam left exactly? Well, so some people have more than one exam. Okay. How many have two? Anybody still have three left? Okay, nice. Anybody have four left? Okay, so 3 wins. This is feedback from assignments 2. If anybody's interested in their feedback sheets. And I guess as part of your preparation for this exam, you've all seen Rogue One. Anybody not see it? So everybody's seen it. Wow, that's impressive. Did anybody watch Rogue One and then watch Part 4? They fit together quite well, actually. I was surprised at how well they fit together. Was anybody else surprised? Were you surprised, Anton, how well they fit together? They really could be almost one movie, like literally like 1 4-hour movie or something. It was.
I only enjoyed Darth Vader. That's all.
Okay.
In the end of Rogue One.
Yeah, that was exciting. That was a high adrenaline scene at the end. This raging serial killer at the end. Yeah. Well, we shouldn't. Well, everybody's seen it, so we're not spoiling it for anybody, right? And I'm going to start this year with another psychic exercise, trying to pick up one of the questions. So one of the questions I'm hearing is, can I pass my own exam? We're going to find, you come here to test me and see, can Bob pass his own exam? Maybe. So I'm just here to answer questions. I'm not here to give any presentations or anything like that. So if you have questions about the exam, I'm happy to answer them. What's your name? Jordan. Question.
When are we expected to implement Runge-Kutta integration? I can't remember.
Remember the formula, you mean? You will not be expected to remember any formulas. And the reason is because I struggle to remember formulas.
Yeah.
But it's possible that you will be given a formula and you will be asked to do something with it, like interpret it or solve it, and so on.
I was reading through the notes earlier as well, and I was going over voxels themselves.
Yeah.
And in what case would a voxel be interpreted?
So that's a good question. In what case would a voxel be interpolated? When you think about interpolation of a voxel, or you would think about these 3 ray sampling techniques, right? That's really something you would think about. So do you remember the 3 ray sampling techniques? The regular sampling, the rasterization or nearest neighbor sampling, and the scan conversion or nearest neighbor, and then the voxel intersections. Yeah. So that if you're thinking about interpolation, those are the generally 3 interpolation schemes.
Okay. Just.
I have a question. For the Euler equation, there is a question coming every year, I think. So,
there's no question that comes every single year, but anyways, there might be questions that come up more than one year.
So there is a 2 seed points which is already given.
Yes.
So how many steps we have to
compute?
Show? Yes.
Well, in that exam, it's only one, right?
Okay.
It's the next one.
Okay.
So usually it's the next one. Yeah. And you've probably seen the video of that already. There's a video where I go through that very carefully, step by step. It's very easy to make a mistake there. So that's why I go through it step by step.
Should we write in the exam step by step or just the answer?
You'd want to do a step by step. You want to show. It's very easy to mess up. You might get a sign wrong, just have a 1 instead of a -1, or a stray half, where it's very easy to mess up. So even when I was answering this question, for a student last year, I did it by hand on my paper, and then when I was doing it on the whiteboard, I was just double checking my paper, like, have I got this right? So it's easy to mess up. Another question, Casey.
What's the difference between data dimensionality and visualization dimensionality?
That is a very good question. So the question, did everybody hear the difference between data dimensionality and visualization dimensionality? That would be a good test question. So data has a dimensionality, and it depends on if you're talking about scientific data or information visualization data. So let's take the case of scientific visualization first. Right, data is generally 1D along a line, 2D arranged in a plane, 3D arranged in a volume, or 4D, which is volume plus time. And you can have different combinations, like 1D time-dependent data, and so on, and 2D time-dependent data. Now, how you visualize those combinations, you can visualize those combinations in many, maybe an infinite number of different ways. So I could visualize 1D data on, for example, a 2D plane and a 2D visualization plane. Or I can visualize 2D data on a 2D plane. I could choose to visualize 2D time-dependent data in a cube, a visualization that's a cube, which is a stack of slices, one slice for each time step, right? So, and now in the case of isosurfacing, so to create isosurfaces, you need 3D data, right? But you don't necessarily output a 3D visualization. You output either what you would call a 1D surface or a 2.5D surface. So you're reducing the dimensionality. So sometimes people call it a 1D surface because it's a surface that consists of one scalar value, one constant scalar value, but it would be fine if you called it a 2.5D surface as well, which is the way I think about surfaces, which is halfway between 2D, a 2D plane, and a 3D volume. Does that make sense for scientific visualization? So the point is, the dimensionality of the data doesn't have to be the same as the dimensionality of the visualization. And very often, the visualization reduces the dimensionality of the data. That happens very often. So another example is when you slice through 3D data. So you have this is very common, you have volumetric data that you want to visualize, and you visualize this using slices, which is 2D. So it's a dimension reduction from 3D down to 2D. Now that's scientific visualization. This is an advanced question, and this is I haven't actually put this on a previous exam, and it's an advanced question, and that's kind of why I didn't put it on a previous exam in some ways. Now let's take the case of information visualization. So the word dimension is not exactly the same for scientific visualization and information visualization. When we think of information visualization or abstract data, you can think of a dimension as corresponding to a column in a table or a spreadsheet, or a column or a field in a database. Like those are data dimensions. And you can have an arbitrary number of data dimensions. Well, you can have an arbitrary number of data dimensions in scientific and information visualization. But that's how you would think of a data dimension in information visualization, and then you have lots and lots of ways to choose visualization dimensions. So you can visualize that data using, for example, a bar chart, which we usually say is one-dimensional, right? But that's very limited. You can use a scatter plot to visualize, a two-dimensional scatter plot to visualize any arbitrary number of information visualization dimensions. So we often say that information visualization data is n-dimensional, meaning it has an arbitrary number of dimensions or an arbitrary number of columns, or in a database or in a spreadsheet. Right, and then we have to choose how many of those to visualize. So in a scatter plot, you're choosing two generally. In a bar chart, you're choosing one visualization dimension, which is just varying height, for example. In a scatter plot, you have the x and y variables that you're visualizing. And then we start with those low-dimensional visualizations, and then we gradually increased to higher dimensions. So for an arbitrary number of dimensions, does anybody know what we can use when we start to get to higher? Andy?
Parallel coordinates.
Parallel coordinates is an arbitrary number, very good, yes. And glyphs was another one, although maybe glyphs, there's always a question, how many dimensions can you visualize? And the same is true for parallel coordinates. We also mentioned scatter plot matrices as a way of trying to scale up the dimensionality for information visualizations. So the point was, there's a data dimensionality, there's a visualization dimensionality. They're not necessarily the same, and there's often a data or a dimension reduction when we apply visualization. Sometimes the dimension reduction, this is a long answer, sometimes the dimension reduction is helpful, and sometimes it's not helpful. Sometimes it's a limitation, right? If you're trying to visualize a spreadsheet with 10 columns with pie charts, then you could say that's a limitation, right? But sometimes, if you have too many dimensions at once and you want to reduce the number of dimensions somehow, right? Because it's hard to manage all of them. Does that answer the question?
Mm-hmm.
Hopefully. It is a challenging question, and it's a good test question. It could be an advanced kind of test question. I would say. It's a good question. Should make a mental note of that for next year. Another question. Say your name again. Rushita. Yes, I remember now.
This is the question from volume visualization.
Yep.
There's two pseudo-codes are given.
Two pseudocodes.
Yes.
Yep. Okay.
And the question is, we have to identify which algorithm will apply for which one.
Yes. Yes.
And the question related with each procedure is that we have to identify which line. The question is which. How can you understand by which line computational speed will be high or low?
Yes. Yes.
So we have to follow. This is a tricky one. We have to follow it's a composite part.
Yep. The
Has to-
compositing. Yes.
Adding
Yes.
color and opacity.
Yes. Correct.
Yeah.
Yep.
Okay. That's the answer.
That is a tricky question. I love that question, by the way. I can't ask you that exact question on this test, though, because one of the algorithms is splatting, the pseudocode. One of them is ray casting, and one of them is splatting. So I can't ask you about splatting in this exam, so I cannot give you that exact question. But it's such a great comparison to see, okay, they have the same structure, but in splatting, some things happen in object space, which in ray casting, they happen in image space, and vice versa. So it's like, okay, can you figure out, because splatting is an object order algorithm, and ray casting is an image order algorithm. So that's the idea. The idea was, it's testing you, can you see which one is splatting and which one is ray casting? And the for each pixel gives away the ray casting, and for each voxel gives away the splatting. So that's what you would use.
So
And-
is it mandatory that if the two procedures will come from the different like one from image order, one from object order, or is it can happen that we can get an algorithm both from from image order, like shear wrap algorithm or
Yeah, so the
convention
shear warp is the hybrid image and
Yeah.
object order.
for fast raycasting.
Yeah. So that would be a valid question if I had pseudocode for raycasting and pseudocode for the shear warp to compare those two. That would be a valid question. Yeah. Maybe that's a good one for next year. Always looking for good questions.
Some
Very good.
questions-
That was a good question, by the way.
Okay, and some questions are from strength and weakness, raycasting, marching cubes. So
Yep. So raycasting, what we were looking for in the strengths and weaknesses of raycasting is a strength would be, for example, image quality for raycasting. You can zoom in and you're resampling the entire image, you're reinterpolating the entire space, so you're getting a high quality image all the time. And you're computing it on a pixel by pixel basis, so you always have this high resolution image. A possible or a candidate weakness would be the speed of the computation. It can be slow. Now, that problem or challenge has been solved in the meantime since that paper was published. But in the context of this module, that still would be considered a disadvantage, so to speak. And for the shear warp algorithm, one of the advantages is speed, right? But a disadvantage might be, for example, image quality if you zoom in on the image. So that can be a problem because the shear warp is requiring this 1-to-1 voxel to pixel ratio. And that constraint is not met when we start to zoom in, for example, or might not be met when we're not at the right zoom level, for example. So that was one of the disadvantages.
Can we talk about marching cubes' strength and weaknesses?
That's a good one too. And I don't talk about it at length. I don't talk about the strengths and weaknesses at length in any lectures. I tend to just mention them at the end when everybody's already tired and can't hear anymore. I tend to just, mention them at the end. I don't know if anybody noticed that. So for marching cubes, one of the advantages of marching cubes, and this is why it's so popular, or one of the reasons it's so popular, is because you don't have to load in all of the data into memory at the same time, all of the volume data. You can load in, theoretically, just one cube at a time. So that means you can produce isosurfaces for arbitrarily large volume data sources, which is a big advantage. In practice, the data is loaded in one slice or two slices at a time. You load in two slices, do your processing, let the slices out from memory, free the memory, and then load in the next two slices. So you slice through the volume data, which is also very good. So you can produce. This is the beauty of that algorithm. Prior algorithms, they wanted you to load in the whole data set at the same time and try to figure out the surfaces. And this is so that was a huge advantage. I would say another advantage of marching cubes is that it's easy to understand in the grand scheme of data visualization. People generally understand it, and therefore they can implement it. Right? Some algorithms are introduced to the community that are not really understandable and can't be implemented. Right? It happens. Disadvantages. So one of the limitations was the ambiguous cases. We did discuss ambiguous cases. So marching cubes can't produce discontinuities in surfaces. So surfaces with holes, for example. There are solutions to that problem, and they are adequate, but they're not perfect, so to speak. You can still always find some case, I think, where you might find a hole. Another disadvantage one could say is that marching cubes produces surfaces that require a lot of triangles. That's not a very big disadvantage, but the main, probably the let's say main disadvantage of marching cubes is that it requires a binary decision to be made. Is this data sample inside or outside the surface?
So it's difficult to measure if the space is very thin or very
The surface is infinitely thin. And in the real world, nothing is infinitely thin, right? I can't think of anything in nature that is infinitely thin. If it's infinitely thin, it doesn't exist. I think. So in marching cubes, you're producing an infinitely thin surface. It has to decide, is this data sample inside or outside or exactly equal, which is very, very unusual. Whereas in reality is not like that. Two reasons. One, because surfaces are not infinitely thin in reality. The other is all data is associated with some level of uncertainty. So a data value, a proper data value, if we were all, anybody here study physics? Or ever studied physics or something like that? So you'll know that if we were studying physics right now, every number that we measure would have to be associated with some uncertainty, like plus or minus some percentage. A thermometer, any measuring instrument, has some uncertainty. You're looking at the temperature, but the temperature is not exact. Things change, and there are errors. And that uncertainty is not part of the algorithm. And so it produces exact solutions, and when there are no exact solutions, let's say. And so it implies certainty. So that's one of the... Now, you wouldn't be expected to go into that much depth. I'm going into a lot of depth in my explanation. You wouldn't be expected to write a full essay on why marching cubes doesn't reflect uncertainty. you would say, oh, you could just have a 2-sentence answer. It requires an exact decision with 100% certainty. You know. And this, some of you might not have fallen asleep at the end of that lecture yet, but then I mentioned at one point, oh, this is part of the inspiration for the ray casting algorithm. Because the ray casting and the direct volume rendering don't require the exact decisions anymore, right? We're just projecting a ray into the data, we're doing our interpolation, and we're compositing. There are no exact decisions that have to be made in this case, and the resulting surfaces can have a thickness, right, and some uncertainty. And maybe be a more accurate reflection of reality. Maybe. Right. Yeah. That was the long answer. Am I passing my own test so far? I remember when I writing these tests, what I really don't like about tests is they require you to work as fast as possible. Usually, it's like a race against the clock. And sometimes my hand would be like in a little bit of pain at the end, you know, with cramps and stuff, trying to write as fast as I can. Anyways, I don't think you're going to have that problem with this test, by the way. Because when you're drawing a diagram or an illustration, you don't have to go as fast as you can. Right? It's when you're writing out something that you have to go as fast as you can, I would say. Casey, did you have your hand raised?
Have we gone over the line integral convolution algorithm?
We didn't get to the line of integral convolution algorithm, unfortunately. I had thought about it. I had considered it because remember we had that one Thursday lecture that it was optional. I was thinking about it, but I was just needing a break, and I think everybody else was needing a break because we had, 12 weeks of uninterrupted work without a break or something crazy like that. So I decided to leave it. But I thought about it. And if you want, I can explain it, but it's not on the test.
What's an intensity profile as well? Because in some of the exams it asks to write the 4 types of ray casting.
Yeah.
And then illustrate its intensity profile. Can you just draw the graph and write what images it would produce? Is that enough?
So the intensity profile is just that 2D line plot. So intensity is on this. I'm not spelling it right. Intensity. And then Z, depth. So it's just the scalar value that you happen to run into at every, Z point along your ray, right? That's an intensity profile. You can that is confusing because this could also be called scalar, scalar value.
Yeah. So if we wrote that, what would we get?
That would
mass, or would it be still right?
I think I would choose scalar value as a better term for that y-axis. Yeah. Other questions?
Yeah, Casey said something about what type of ray casting. So can we call it like classification of ray casting? They are the same thing or not?
Classification of raycraft. Really what this is about is transfer functions. That's what this is really about.
Not ray casting, but
It's a ray function, 4-ray function.
That's right.
Yeah.
Yeah. And they fit in the context of transfer functions, right? Because they're transferring different subsets of the volume data to the image plane, right?
yeah,
That's how I think of it at least. Yeah.
I just confused.
Yeah, the term, there's a lot of terminology, new terminology in this module. Yes. And it is confusing. It is. It evolves very organically. and it's confusing.
So can we talk about construction of the stream surfaces challenges?
The challenges of constructing stream surfaces. Is that from a previous test?
Yeah.
What is does it ask first for the general algorithm and then say what are the challenges, or is it part of the algorithm question? Do you remember?
Let me. It was. I don't remember the question. Yeah, there was something about algorithm, and also there was a relation between this topic and convergence, shear, and divergence. I don't remember exactly the question.
Okay, so it depends on how the question is worded, but there could definitely be a question like outline the major steps of the stream surface construction algorithm, and maybe provide illustrations to support your answer. And you would bring up the challenges of convergence, divergence, and shear.
Exactly.
Yeah, those are three challenges in the context of constructing stream surfaces. Yeah.
Do you know if you're asked to describe the algorithm, do you write it out as an algorithm, like a pseudocode, or can you write it out like a flowchart?
Either is fine. Either is fine. I'm going to be looking, just to see, does this person understand the steps of the algorithm? Not exactly. So you have different options. I didn't even think of the flowchart. Well, some of the slides do use the flowchart, don't they? The stream surface lecture uses the flowcharts. The marching cubes lecture uses just a list.
Yeah.
And the shear warp does use the pseudocode. I didn't even think of that. But yes, all three are valid options. Yeah, definitely.
And one I think is the pseudo-code run length.
For run length encoding, yeah. That's right. The shear warp algorithm, the run length encoding, yeah. I think if I was a student, I would probably try to just compose a list of the steps and then provide illustrations and further descriptions. I think that's what I would say, okay, let me just first jot down the list of the steps, see if I can remember and get the order right, and then go into more detail after I've got the basic steps in place. I think that's how I would do it. Does anybody? Well, I don't. This is getting off on a tangent, but I have a strategy for preparing for tests. A personal strategy. I don't know if that's interesting to people or not. So I was a student for a long time, much longer than all of you guys, and I took a lot of tests. And I actually always wanted to kind of publish a strategy, because there are strategies for preparing for tests. It does depend a little bit on the type of person you are, what your strengths and weaknesses are. But my generic strategy that I developed, that I didn't really finalize until I was coming up to graduation, like maybe my fourth year of my bachelor's degree, where I really thought, oh, this is a very good strategy for all tests, that I then used, when I could have. I wish I had known it when I was in first year. You have, for all of your classes, you start with a pile of 100 pages of documentation, right? Like in slides and reading and all this stuff. So I think the best strategy for preparing for a test is to boil it down to 1 or 2 pages of essentials, the most essential things. And that's a great way to study, to prepare for a test. What do I mean by that? That's difficult, isn't it? It's difficult to start with 100 pages of material or whatever you're given, and then filter it down or summarize it into 2 pages, maybe one or 2 pages, one on each side of an A4 sheet of paper. So what you have to do is you have to go through all the material and you have to figure out, okay, what is the most essential information from all of this? And then what I would do is I would have like a 2-pass algorithm. I would go through my list of information and I would take notes on what I believed to be the absolute essential information. And I would boil it down to some number of pages, like 10, maybe, for example. And then I would go through that 10 pages and say, okay, of this 10 pages, what is the absolute most essential information that I need to remember for the test? Like, if I were to bring these 2 sheets of paper, if I was allowed to bring 1 or 2 sheets of paper into a test, what are those 1 or 2 sheets of paper that I would be bringing in? That's what you're trying to construct. Those 1 or 2 sheets of paper that you wish you could bring in as a cheat sheet for the test. Right? That we were allowed to do that in some of our classes in the US, to bring in one side of notes or whatever, and then you'd be writing in this very small font, right? Like tiny little font. But that is great preparation for a test for a number of reasons. You go through all the material systematically. You are forced to decide what is the most essential information, what's the most important, what's not so important. So you have a systematic way of reviewing the material, and then you do it a second time, right? You're like, oh wow, this is difficult. If now I have to really decide what is the information I wish I could bring into the exam, and then you write that in small font on your 1 or 2-sided sheet of paper, and then, right? I'm not very good at memorization. This is was always one of my weak points. My mind is made for solving problems, finding analytical solutions to problems, rather than just memorizing. So, I don't know if you've ever been like waiting for a test to start and then panicking, and then thinking, oh, I forgot everything. Like I'm panicking. I forgot. I can't remember anything. You have that 1 or 2-sided sheet of paper that you're looking at right up until the test starts. Like, you're looking at that sheet of paper, at least for me, that's how I did it. I was looking at this sheet of paper right up until they said, okay, you're allowed to go take your seat. So I had all the essential information freshly in my short-term memory, right there, you know. And I found that so helpful. And sometimes what I would do, you're not allowed to bring anything into the exam. Sometimes what I would do is like, oh, I know I'm going to forget that formula. So I'm looking at the sheet, and then as soon as I start the test, I just write down those formulas that I know I'm going to forget, right? Before I even start the test, like, oh, I'm going to write down those formulas that I think are absolutely essential before I forget them. I even got caught. I took a test not very long ago where I did this same strategy. It was the immigration test to stay in the UK. You know, if you want to be a permanent resident in the UK, you have to take a test. I used that exact same strategy from whatever a number of years ago, and I got into the testing hall, and I started writing down all this stuff, the stuff that I had to have memorized in a little table. And the woman that was giving the test accused me of cheating. I was like, no, I just wrote this stuff down right now. I swear I didn't like fabricate it and pull it out of somewhere. I said, I just wrote this stuff down. But she accused me of cheating. She's like, how do you know all that stuff? Or whatever. Just because I had my 2 sheets, you know, trying to just keep it in my brain for the test. So it's a great strategy for preparing for a test, and it works for, in my opinion, all tests. Right? Anyway, just hope that helps somebody. Any other questions?
I was going through your video series on YouTube for the
Yeah.
lectures. Did you take one? I think there was one missing as well. Just wondering if you took.
There
that
are two
video.
missing.
You took
One is the introduction to FlowViz, and the other is the stream surface construction. So those two are missing. Something went wrong with the laptop. Yeah. Yep. So the introduction to FlowViz is not the most exciting lecture. So if you still have the slides and you can see what we talked about there. I don't think there are any algorithms. And then the stream surface construction is kind of similar to the streak surface, kind of, they have some things in common. That would be a great test question. What are the differences between stream and streak surfaces? Like identify the differences and compare and contrast the two construction algorithms. The essential difference is, well, the streak surfaces are time dependent, right? And they have these T-junctions that have to be managed. And they're kind of complicated, T-junctions, in the streak surfaces case. Stream surfaces are much simpler in that sense.
Is these are only split into info, volume, and flow?
It might be split that way, but I can't guarantee it. I would not say it's definitely going to split into be InfoViz, VolViz, and FlowViz. There's another category called introductory material, right? And that can go anywhere. But I could decide one year, I'm going to mix up InfoViz and VolViz into one. I could do that one year. But the introductory material could appear anywhere, right? That's in general. And I've had exams where it is just introductory material. One question is introductory material, and then one is, another subject, and another one is another subject.
With parallel coordinates, on your video on YouTube, you start at 0 and then go up for every single attribute row thing. But can you just start at any number, like the minimum number?
You can, you can start at any number, and the axes, the range of the axes is arbitrary. It's the author Alfred Inselberg likes it if you have the 0 line explicitly. He told me that. He's like, you have to have the 0 line. Like, that's a rule. And so I try to mention that, but you don't have to have the 0 line. It's good practice to have the 0 line, but it's not absolutely essential. Let's say, Alfred, I hope he forgives me for saying that. It's encouraged, let's say. But you can imagine implementations of parallel coordinates that zoom in and out of arbitrary axes and changes the ranges. Like the user can change the range and so on. If there's a large concentration of polylines in one area and you just want to zoom in by changing, you can imagine doing that. Any other questions or concerns? How many other revision lectures are you having this month?
No.
Is everybody giving a revision lecture?
No.
Okay. Just curious.
We got
Which one?
for the operating system
Operating
on 30th.
systems. Okay, who's running that?
Dr. Mora.
Okay, good. I'm just curious, that's all. So everybody has all of their questions answered.
There's one where you have, I think it might be parallel coordinates. Oh, this graph thing. And we have to make, first of all, choose
Yes.
the visualization, and
Yeah.
then see if we can make it into a tree map.
Okay, yep.
I could argue that it could be a tree map, and I can argue that it shouldn't be a tree map. So which one would I go for then?
Well, do you remember assignment 1?
Maybe.
So assignment 1 was you're given a data set and then create a bunch of visualizations. So you can make any data set, including that one, into a hierarchical data set. And that's what you need for a tree map. Is it hierarchical? How does anybody know how you would do that? How you can a generic way to turn any data set like that one in a spreadsheet into a hierarchical data set?
I'm gonna do it like students, and then each of the subjects, or each subject and then each student.
You introduce categories. So if you have, what are those, what's that example?
Students and subjects.
So for example, you could split the subjects into arts and humanities as a category, arts and humanities topics, and then scientific topics, and introduce a hierarchy that way, right? And the students you could split into like students have to be split up in into the top, the middle, and the bottom, right? That's how students have to be. Well, that's what I'm supposed to do is to do this system. So you introduce categories. You can always introduce categories for any data and split it up that way. And the most generic way is just, the absolute most generic way is just to split it up based on percentages, like bottom 10%, 20 to 30%, and so on. And for like the other data, the most generic way to split up data in the form of alphanumeric data is just alphabetically. That's the most generic way. Like the letters from A to F is one category, and the letters from G to N is the next category. It's the most generic way to split up that kind of nominal data. But you can always take any data set and group it into categories, and then that's how you would create your hierarchical data. And so the answer is yes, you can generate a tree map from that data, but you introduce categories.
Yeah.
So that was part of assignment 1, was you were encouraged to introduce or group data into categories so that you could apply hierarchical visualizations to it.
Question.
Yeah.
When you ask us to visualize some set of data, are we required to visualize with some certain types or any type of visualization?
Depends on what the question asks.
Sometimes you just ask
What type is appropriate, for example?
yeah, just visualize that set of data. You don't specify what type.
Exactly. Yeah, so then you have to choose something, and you have to say why you've chosen it. Yeah, and hopefully you've chosen something that makes sense.
I mean, in assignment 1, you asked us not to use some of the visualizations.
That's right.
So does that the same apply for the exam?
So it depends. If you're given volume data and you say I want to visualize this with a pie chart, you might get points off. It's possible. So some visualizations are more important or more appropriate for certain types of data than others. So you have to justify your choice and say why you chose that, and hopefully it makes sense. Yeah, for example, in one that Casey has of this table of data, if you said, okay, I'm going to visualize this with a 2D scatter plot, then I would say, okay, but what happened to the other dimensions? You have 2 there. What about the other ones? Have you factored in all the dimensions? It is possible. It is possible, but but you'd have to. I would be wanting to see that. If that makes any sense. Yeah. Which one are you looking at? Are you looking at a specific question?
No.
Just a generic one. Okay. Any other questions? I'm gonna maybe use my psychic powers to try and get some waves of questions. You're welcome to ask questions between now and the exam. I guess it's on Thursday?
Wednesday.
Wednesday, okay. Or the 25th. Wednesday the 25th, yeah. Okay. I don't encourage you to wait until the last, Tuesday to ask your questions. I did have a few questions on the last day last year, and I tried to answer them in time, but I didn't answer 1 or 2 in time. It was too late. I tried to. The one there was a FlowViz question last year at the last minute, and I did answer it, but it was too late. So.
Is it? I think it is not enough 2 hours for the
the
explanation and illustration. You have to draw lots of diagrams
that's it.
for the good answer.
Yeah, that's this class was some people in this class were really worried about assignment 2, but the scores on assignment 2 were very high, like really high. The average was something like a 73, something like that. So you might say, oh, this test is going to be really hard, I need more than 2 hours, but I had a student complain that the test was too easy once, and I got scolded by some staff members for making the test too easy. Yeah, so I don't think you're going to struggle really to with the time limit. That's my opinion, but if you do, you can tell me afterwards and say, look, I needed another half an hour on this exam. Let me know. And you can say why, like, oh, I couldn't answer this question. I didn't have enough time to answer this question. But I haven't got that feedback in previous years. Any other questions?
Are you going to be available on Monday?
On Monday, that's a. I should be around on Monday. Yeah, I should be around. I have a meeting at 11 on Monday. Let me check and see if there are any other things in my calendar on Monday, just to see. Okay, that's the only thing. And on Wednesday, I have a meeting at 11 too. I can tell you I have a big deadline on the 26th for 2 research papers, but I think that my involvement in those papers will end on the 24th. Yeah, so I'll be around on Monday. Is anybody panicking on this exam? This is not an exam that's worth panicking over.
Only because it says it's going to be harder.
So Casey has an exam where you're given a data set, and Rashida had an exam where you're given pseudo-code to start with. In this exam, you're not generally given those things to start with. Yeah, so that's a difference. That's a difference. You're not given a data set necessarily. You might be asked to provide a sample data set, or you might be asked to produce some pseudocode or outline of an algorithm rather than being given one and then asking, some questions about it. So it is more challenging. It is more challenging, but this class is smarter as well. And you're more well prepared. This is the most well prepared, most well equipped class that I've ever had. Because you get to see the material as many times as you like. And I'm sure the Chinese students really appreciate this because you can see hear the language repeatedly, right? If you don't understand the language.
Videos are very helpful.
Yeah, I never took a class where that was an option. That was never an option for me personally. So, yeah. It's like I'm investing more and I have higher expectations and I'm asking for more. But ultimately, it's a better education ultimately. It's you're if I can ask you for more, it means you know more. You're more of an expert and you're more knowledgeable in data visualization than you would have been otherwise. So ultimately, it's giving you more and asking for more in return and making you brighter in the process. And by the way, this subject is a great subject. Industry is dying for competence in data visualization, dying, literally. But they are very, very, I get companies all the time approaching me saying, please, Bob, please, do you have any students that are good at data visualization that we can hire? Please. And they pay me money. I've got £5,000 in money for companies saying, I will pay you £5,000 if you can supply me with a DataVis student, somebody that's good at DataVis. Very few lecturers can stand up in front of you and say that. In fact, it would be very difficult to find another lecturer that can say that. There are a few, but you're going to have trouble finding them. So the demand is really high, and it's a great topic, and everybody knows why. That's a good test question, by the way. So it's the
To solve data chaos.
it's because everybody's collecting endless amounts of data now. Yeah. Questions? See, everybody's psyched to take the test. They can't wait. Bring it on! Yes! So yeah, we'll stop if there are further questions. Happy Friday. I'm guessing there are no further questions. Let's not worry about that.
How do you answer this kind of question? What does your algorithm help you with?
Yes, that's a good question.
It's a
You know
tree
which? That's right. So you say it outputs a tree map.
But also, it also asks for what kind of visualization. It's the same?
Well, a tree map is a hierarchical visualization, so information
Does that
visualization.
also answer the last question? So why do we have
No, it's not
output
the
here?
same question. It's not the same question. The first part's looking for, it's a tree map visualization, so it's a hierarchical visualization, usually is an information visualization. The second part is an output. You could also say it outputs a tree map, but really also I'm hoping you're going to say it outputs as a set of rectangles. that are arranged in a tree node, for example. That's part of the answer. And what does it actually say there?
Set of source.
Okay, position line size. Okay, name method. Okay.
It's according to percentage.
Yeah. So a set of rectangles is a good answer. Arranged in a tree node.
Write an
Yeah.
algorithm.
So are we still going to choose 2 out of 3 questions?
Yeah, that's the part that makes it so easy.
Yeah, we then choose 2 topics.
It's so
Give the code, we will
So are you going to mix them?
I like really probably I have not mixed them really, except for the intro stuff.
Yeah, the intro is.
But I should mix them in the future. So because what ends up happening is people say, "Oh, I'm just gonna not study the flow of this stuff," and that's not really what I want. You know, so I'll probably start mixing them up more in future years.
Is there a difference between level 3 and level M?
No, not this time because it's a master's level module and then you're allowed, it's opened up to the 3rd year. So it used to be 2 separate modules, so there were differences, but now it's just a master's level module, so the 3rd years do the same work as the master's.
Okay, you mentioned in the last revision actually we're going to use a lot of illustrations.
Yes.
We get more points to use that.
Correct illustrations, yes. Yes. Almost, maybe all the questions, as many questions as I could. I always ask for illustrations. And I like this so much better. I prefer illustrations over, say, show me the, like, recite the definition of an isosurface. I would much rather say something like, illustrate an isosurface or something rather than, recite the definition of an isosurface or something like that. Well, you get the idea. So I prefer, and it's visualization, right? It's about shapes and drawings and
Okay, I can write
those
this.
sorts of things.
Sure, bro.
I have a question.
A tricky one.
So draw. If I draw and leaf, okay?
I can raise this thing.
So what do you ask? Let's go first.
Okay, flow glyph, yeah.
First. Points. Okay, so we have magnitude, we have x, y, we have time, and we have temperature.
Yeah.
What can we add here to express the curvature?
Well, the curvature is already expressed in this curve.
Really?
Yeah,
Oh, so points will be just
that's
for
right. That's right. When you connect the curve, you're expressing the curvature when you connect the points.
Fine. That
Yeah.
was
You could encode other things, by the way. So if you consider this a glyph, you can keep encoding stuff. For example, you could like add a thickness and encode something in a thickness. For example, convergence and divergence. Like this is converging flow, and for diverging flow, and so on. So there's always ways to add more things almost all well. And then there's the color. Like you could code something with color. Here, this color here.
so
The width of this thing could change, and the length could change. Maybe even the shape could change somehow. So and the length of this could change as well. Like some could be really short.
Use a set of strict
So there's lots of things that
lines.
could be encoded.
What did you ask?
Yeah.
You will.
More questions.
they fill with the dimensions.
Anton, there is a video, YouTube video.
Yes, but it doesn't cover both questions.
So we didn't talk about line integral
There is a video
convolution this time.
YouTube
If you're
It doesn't cover
curious,
that.
the input to this, the line convolution integral algorithm is a vector field, a flow field, and a texture of noise. Those are the two inputs. But you don't have to know that for this example.
Business study.
Should we just write
What about data?
Okay, so for this question, it's asking if you want to know what this algorithm is. It wants to know if you understand that algorithm. So
you can cook.
the answer is it constructs a tree map.
Yeah, we know that.
What does it output? Well, it outputs a tree map, and which is a set of rectangles.
I already told, but maybe we thought that we will get something different. Just rectangular, but something else. We already
It's a set of
told it,
rectangles. Yeah, a set of
something different you
rectangles.
expect to see, right?
It's so a set of rectangles that are arranged in a hierarchical tree map.
Only for me?
Yeah,
For you guys.
that's the idea behind that one.
You see?
So then you would instruct
we
that
have
you
a deal.
actually draw the tree map, right? That's so you would
When are you leaving?
draw a tree map and you break some data, right? And that requires that you have some hierarchical data.
And you? So the hierarchical is for the input? Yes.
Yeah, that's right. Hierarchical data. That's right. Is the input.
Data and width and height of the rectangular, it should be input, no?
No.
But
It's computed.
yeah, but the beginning.
It's computed based on the algorithm. Yeah.
So height is computed.
Okay.
So identify and describe two weaknesses with this type of visualization associated with the pseudo-codes, which is propose at least one way in which this disadvantage may be resolved. So one of the weaknesses with some of the tree map algorithms is they can produce long, thin rectangles. So that's a weakness, because imagine you're trying to compare the size of a long, thin rectangle with another rectangle that's almost a square. It's kind of, maybe it's not impossible, but it's difficult. In the ideal world, all of the rectangles would be squares, and those are easy to compare. Or the same width bars or something like that. Another disadvantage that's possible is it's more difficult. It's not impossible, but it's more difficult to apply the tree map viz to multivariate data. It's not impossible, but it's more difficult. It's meant for hierarchical univariates generally.
So if you ask a marching key, we need to mention about the steps. So
That's right.
So we need to draw all. While we're explaining the all steps, should we draw all?
15 cases of the marching cube space.
No, come on.
Joey, you would have scored more.
Guys, we can draw this.
Yeah, I know, but it would be great if you could draw one or two,
Yeah.
like the first two, for example.
First one.
Oh, there's one. Yeah, great.
Oh, first one, and maybe second one.
I forgot to mention, some people say that one of the disadvantages with marching cubes is that it spends a lot of time processing empty cells. So most cells, it's true, are empty. Most cells don't intersect the isosurface. So that's you could add that as a disadvantage if you wanted to. Yeah, I don't think that's a very important thing, but some people have mentioned that.
I have a question. You said here that name an appropriate visualization for the data shown. Do you
Yeah.
mean like the information or the type of visualization?
The type, the design. So for this one, I'm really looking for parallel coordinates.
sure.
And the,
There's no other
This
option.
this
Yeah.
this is the only answer.
There's
it's not the only answer. No, you could say
For this one, you
Yeah.
No, you could say we talked about different multivariate algorithms. Scatter plot matrix is a valid answer. You could try it. A glyph is a valid answer. I wouldn't choose it myself, but if you said, oh, you could use a car glyph to visualize this data, and you map the different things, like the color of the car represents its maximum speed, and the length of the car is mapped to something else, and the height is mapped to something else, and the size of the tires is mapped. That would be a valid answer, you know. So yes, the easy answer, in my opinion, is parallel coordinates, but there are other correct answers that are acceptable, which is another reason why the test is too easy.
I honestly don't know why you think it's supposed to be. It's like an easy one. I don't think
Okay.
it's easy.
Okay, what were you thinking? Did you have a guess before I answered? Like, what would
It
you
could
have?
be. I thought that you're asking about the information itself and the
Okay,
visualization.
Okay, so you were.
And also
Struggling
they
to-
have the option to choose like 2 questions out of 3.
This makes it much easier. Makes it too easy.
Like you're just making the exam harder by just not giving us that option.
I think it's more difficult if you have no option, if you must
Yes.
answer all 3, right?
Yeah.
So
No, just 2 questions.
Yeah, just
So
a question
easy.
and it covers all topics.
that's why it's quick too.
Is
Yeah,
there
because
Yeah.
I met a
I've
student
been
who
curious.
took the course with you like two years ago, and he said that as far as I know, just focus in 2 topics, not all the 3, which is amazing.
I don't think that's very good advice. Firstly, there are 4 topics. There's introduction,
Yeah.
then InfoVis, then Volvis, and then. So don't forget that. But you know, what if you get a Volvis question that you really don't know the answer to, like, and then you say, oh, I didn't study the FlowVis stuff, so I can't answer that, and now I'm stuck with this Volvis question that I don't know the answer
Yeah,
to.
I wouldn't do it, but like he was
it's-
comfortable.
A lot of people do
Yeah.
that. Yeah, I know. A lot of people just say, "Oh, I'm gonna forget the FlowVis stuff," you know. And yeah, I don't think it's a good strategy. But maybe I'll change that someday. And
Other lectures already.
He already changed it for us.
Yeah, already changed it. I also.
if the scores are ridiculously high this year, then I'll change it. You know, outline the evenly spaced. So we went over that in class, right? There's a lecture on that.
It's George diagram like that.
Yeah.
Oh wait, I don't remember which one.
Yeah.
You
we did the
choose.
flow one. Yeah.
So
Yeah,
step
okay.
1 is you choose a random seed, probably in the middle, and then you trace a streamline forward and backward until you have your terminating conditions, and then you put that streamline in a queue, the queue data structure, so to speak, and then you search along the streamline on both sides of it for spaces to seed another streamline d-sep away, right? And as soon as you find a space, you plant the streamline there, integrate forward and backward as far as you can, and that one goes into the queue. And then you return to the one you were searching on, and you repeat that process. So that's the basic idea. And then that kind of question always has something like, okay, well, what are the 2 most important parameters? And then you have to know d-sep and d-tests. And another possibility is, okay, what are the terminating conditions for a streamline, right? It gets too close to another streamline, it exits the boundary, it's too long, or it hits a critical point, like a sink or a source, or any time the velocity approaches 0. Yeah.
What is the difference between asking us what can we learn about cars from the visualization, and what is one conclusion that can be drawn about the cars?
That's the same question, really.
Can I answer
We-
this
well-
question by relating, like showing the relationship between two columns?
What it's looking for is, with this kind of visualization, imagine you had chosen parallel coordinates, for example, or scatter plot matrix or glyph. You can start to analyze the relationships between the different variables. That's what that's looking for as an answer.
Well-
So these visualizations are designed such that you can start to look at the relationships between different variables. And then this one is looking for a specific thing, like, oh, I can see that as the engine size increases, so does the miles per gallon decreases, or the petrol consumption, which is not a very exciting example. Or I can see that all the cars from the US use the most petrol
Yeah.
if you actually, draw it out and everything. And that corresponds to assignment 1, the observations. Remember, it asks for an observation, like, here's the thing, now what can you observe?
Information, okay, but flow is a bit difficult.
Flow is difficult. Some people say that's the most difficult. Yeah, I think for me, I would say the most difficult is computing streamlines C points, like by hand.
1 minute.
1 minute.
That's I just think that's the most difficult part.
Struggling.
So did you ask this question? Because I didn't know the answer.
I could answer only those questions.
Anthony, you know the answer of it? What is this question? Someone can explain?
Radius. What are
Consider
coordinates
the-
of this?
But
Yes.
this is different.
Yeah,
Of
this
course, I know.
Consider this- So this is the Cartesian coordinate system. Visualize the same data using parallel coordinates. In other words, can you transform this into a parallel coordinates visualization?
Yes.
That's what it's testing you on. So it wants you to take this axis and this axis, move it over here, and then for each point, you have to draw the corresponding
Easy.
edge. Yeah, that's the idea. A good question might be like, here's a parallel coordinates visualization, now draw the Cartesian one. That could be a fun question too.
But we don't know the exact.
That's true. That's true. You have to use your best estimate.
Okay.
Like if I was doing this, I would try to.
1.8, for example.
Oh, okay, yeah. I would try to say, okay, that's one, and this is looks like 1.6 or something.
Yeah, this one is good.
And this one is definitely 1, and that one looks like 1.6.
Yeah.
Yeah, it's a circle. Well, you could it approximates a circle,
Right.
so you can. But anyways,
Yeah, I just
you
wanted
have
to
to
make sure.
approximate. And then I think the idea also is something like, if you have a circle in Cartesian coordinates, what shape does that produce in parallel coordinates? And if I remember, it's a star or something like that. So like shapes, there are shapes in Cartesian space, and then they correspond to other shapes in parallel space. And just to see, oh, that's interesting, like this turns out to be that, and so on. That's kind of the spirit behind that too.
But,
50?
Yeah. I
Nice
told it
one,
over.
23.
How many 100 is there? Are there?
I don't know.
But I saw many.
You're not supposed to look at the other students.
Okay, I shall look at all of them.
The statistics are on Blackboard, right? The average and all that stuff, right?
Should we expect finishes? Because you seem like stopping
Yeah, you can still be asked definitions. It's a very, generic starting point, like, just to start some things.
Should we study based on the past exam for definitions? Because there are many definitions.
Crazy
so,
many.
Yeah.
Really? How many?
Many.
Many,
many.
many.
So,
20?
No, it's not 20. Are you serious?
Definitely
more
more
than
than that.
20.
It's definitely
Maybe
more than
30.
Really? I would be very curious to see how many, actually. I don't think there are that many.
I don't know. Like in each slide, you could ask anything, define or whatever.
I don't need
At least.
The other thing is, remember how I was saying, like, that the ideal test preparation process, which is amazing, by the way.
Yeah, I know.
I've already helped you with that, because I produced a one-sided spreadsheet for you guys.
Yep.
Bam.
And still, then each term refers to one definition.
That's right, so you could go through that
Construction
spreadsheet
of
and
the
say,
voxel.
okay, what is it here that I wish that I had on a sheet of A4? Because some of the stuff you're just gonna be like, oh, I know that, I know that, I know that, I know that, I don't need to have that on a sheet of A4. Then you could go through that spreadsheet and say, okay, this is the stuff that I don't know about that I wish I had on a sheet of A4.
So, this
So
is
a lot of work has already been done, actually. And if you, I don't know about you guys, but I always had these sort of worries that I would wake up in the morning and I wouldn't be able to remember anything, and I would be just consumed by worry. And so I as a comfort mechanism, I would have my sheet of A4. I'm going to bring my sheet of A4 with me so I can look at it and stare at it and just comfort myself right up until the exam, instead of wandering around going, okay, remember this? It's a great strategy.
But when you sit down, you forget everything.
yeah, but this is also true, but English is not our native language, so it's really tough to remember all words with the same order. I don't know, maybe I have big memory about remembering the English words. I understood it, but while I'm writing, everything is mixed.
Repetition.
Yeah, it's right. Yeah, practice for learning.
So this is the beauty of DataVis. You're going to be asked to draw things. So your language is not going to be that much of an issue.
What if they can do that?
So,
That's good. Thank you so much for your
my pleasure. My pleasure. I hope I can put it on YouTube, this one as well. I think I would be able to pass my own tests.